Hello, and welcome to today's lesson where we're going to look at the relationship between the ratio of side lengths or the ratio of areas. And now we're going to add in the third part, which would be the ratio of volumes. Okay, so we've done all of these calculations in a single sense. We've calculated areas, we've calculated our volumes, we've found side lengths. And we're going to see how all three of those values end up relating to one another. Okay, so now, if we look at these cones, are these cones similar? Okay, we can prove if they're similar, okay, by using side-side similarity. Okay, so we're looking at the side lengths of the cones. Okay, we know we don't have to worry about angles here because of the 360-degree nature of the circle at the bottom of the cone. So if we set up our ratios, 8 over 14 equals 12 over 21, okay, making sure that we're using and aligning the proper values. When we cross multiply, 8 times 21, 168. Equals 12 over 21, or equals 14 times 12, excuse me, which is 168. Okay, so now I've used cross multiplication to prove that these are similar figures. The other thing I could do here is look at reducing both of the ratios. I know that 8 and 14 could both be divided by 2. And I have 4 and 7 for that ratio. 12 and 21 could both be divided by 3. And when I do that, I get 4 over 7. Okay, so I can always cross multiply to see if they're similar, or I can get them into their reduced terms, which would be their side length ratio. Okay, we always want our ratios in lowest terms possible. Now, in our last video, we talked about the area ratio, which is just taking our side length ratio and squaring it, so 16/49. And hopefully now you can kind of plan out and see what's going to happen in a volume situation, which is units cubed, and this is units squared. Okay, all we would do is take the side length ratio and we would cube that value. So 4 cubed is 64, 7 cubed is 343. Okay, so once we know one of these ratios, it doesn't matter which one, we can find all of the others. So if we know side lengths, we square it to turn it into an area ratio. We cube it to turn it into a volume ratio. If we know the area ratio, we can square root it to turn it into a side length, and then we can cube it to turn it into a volume. Okay, so there's a lot of manipulation that we can do with these values as we work along. Okay, so now, the triangular pyramids that were shown here are similar, so we're told that right off the bat. We're given a ratio of heights, and what we want to remember is height is a side or a length. Side and length values are one-dimensional values. So if I want to turn this ratio into something that I can use in 3 dimensions, I have to turn the side ratio of 3 to 5 into a volume ratio, which means I take the 3 to 5 and cube it. So now I've got 9 over 125. And now I've got a ratio that I can use to find the volume of the large pyramid. Okay, so I have a ratio of small to large. I know the actual volume of the small pyramid, And what we're solving for is the large pyramid. Okay, once we have this set up, it's just a cross multiply and solve situation. Okay, so we've got 125 times 81. So 9x equals 10,125. We divide that by 9, and we get x equals 1,125 centimeters cubed. Okay, remember, when we're dealing with volume, when we're dealing with area, we want to make sure that we're using the proper units. Okay, now, how do we go backwards? Okay, when we are going backwards, we have the volume ratio. Okay, so we know that the volumes, so our volume ratio is 512 pi over 1728 pi. Now, we can see that there's a pi on both levels, so we can cancel those out. And now, the simplest way to get the exact volume ratio, because I can see this one is both a multiple. Okay, I can divide both of those by at least 2, if nothing else. So the simplest way to do this on your calculator is to divide 512 by 1728. And now you're going to get this ugly looking decimal. 0.29629. Okay, so we can see that it is a repeating decimal that goes on forever. Okay, that's not a ratio. That's not something that we can work with. Okay, but in your calculator, you should have the option, and it's usually under the math function in your calculator. Okay, so if you find the math function in your calculator, you're going to see something that says arrowfrac is that second option. And if you go to that arrowfrac and hit enter, what you're going to do is you're going to convert that decimal back into a fraction in simplest form. So now we've done the simplifying part where we could have divided by 2 and kept going. You can see we would have to divide by 2 a couple times to get down to the values that we have there. But by just doing the simple division, turning it into a decimal value, understanding how we can convert from a decimal to a fraction really makes our life a lot easier. So now I have my volume ratio, and I need to turn this into a side ratio. Okay, now to turn it into a side ratio, we have to undo the cubing of this value. So if I want to undo the cubing, I take that 8/27 and I have to raise it to the power of 1/3. Okay, so this is what we call a cubed root. So we're doing a cubed root of that value. So now we take that 8/27 to the power of 1/3, and now I'm going to move over here back to the left. I'm going to get a side ratio of 2/3. So when I look at my two shapes, I can see that 6 is the height of the large cylinder. So the 6 is going to go on the bottom with the 3. X is the height of the small cylinder. So I'm going to put the X with the 2. And then now I can cross multiply and solve to finish this up. 3x equals 12. X equals 4 centimeters. And that is the height of the small cylinder. Okay, so I want to walk through these steps one more time really quick. Okay, we set up our ratio, small to large volumes. We can get rid of the pi because it's the same value numerator and denominator, so it divides out to 1. enter it into your calculator to get the decimal value. In your calculator, use the math and then convert to fraction buttons. Okay, that will give you the simplest form fraction. And then once we have that simplest form fraction, then we cube root it or raise it to the power of 1/3. And that ends up giving us our side ratio for the length values. Okay, because now let's look at, once again, we saw this chart in the last lesson. If your side length ratio is m over n, your area ratio is m over n squared. Your volume ratio is m over n cubed. Okay, so notice the base of all of these ratios is the same thing. It's the side length ratio. So if you're given an area ratio, we square root to turn it into a side length ratio. If you're given the volume ratio, we cube root or use the power of 1/3 to turn it into a side length ratio. Now, one important piece when you're cube rooting, make sure that you put your parentheses in place. Is it always needed? No, but it's always good to protect any fraction in a problem with parentheses to make sure that your calculator is going to work properly for you. Okay, so now let's look at this situation. We're given volumes. Okay, so we can build a volume ratio, but understand we want to find what's the area, what's the ratio of the areas here. So what we're going to have to do is take this volume ratio. Now we can see it's not in reduced form. So what we're going to do here is we're going to find the decimal value first. You know, what is 24 divided by 192? Okay, 0.125. Okay, once we get that decimal, we're going to use the math fraction conversion, and it's going to give us the ratio of 1/8. Okay, so we have a volume ratio of 1/8. Okay, so that is our volume ratio. Now, the next thing we need to do is turn it into a side ratio first. We need to take the 1/8 to the power of 1/3 to turn it into the side ratio. Okay, so this is all together as the side ratio of 1/2. And then now, once I have the side ratio, I can take that side ratio, square it, and turn it into an area ratio of 1/4. Okay, so let's look at this problem again real quick. Okay, we started with the actual volumes that we were given, setting up our ratio, finding the decimal value. Once you have the decimal value, we want to convert it to a simplest fraction by using our math frac option. Okay, so we get our volume ratio of 1/8. Now, you can't go directly from volume to area. You always got to go down to the side length first and then use the side length to find the area. So to undo the cubing, okay, so to undo your cubing, we have to use to the power of 1/3 or the cubed root to get us down to that 1/2 side length ratio. And then turning it from a side length to an area, we have to square it to finish that process. Okay, so that is the end of our lesson here today, looking at how we can use the volume ratio along with the side length ratio and the area ratio. Thank you and have a good day.